Amplifier. Under this topic, we are going to study, under this chapter, we are going to study the topics like concept of amplification, amplifier notation, amplifier gain, Decibel gain, frequency response of amplifier, bandwidth of amplifier. Concept of amplifier. Amplification means amplification of weak signal. The circuit that do the amplification is usually known as amplifier. The basic function of amplifier is raise the strength of weak signal. Here means the amplification is a process which increase the magnitude of signal to a limit without general change in any shape. Now, as you see from the block diagram, amplifier is a four-terminal device. Two acts like an input, other two acts like a output. In input terminal, we attach the source between the 2 points, and at the output terminals, we attach some types of load in between. This load may be a loudspeaker, relay, or any type of motor. Amplifier requires at least one active device, such as transistor, vacuum tube, to amplify this low input signal. The active device need DC supply that is supplied by the DC source. This DC to AC conversion is done by the active devices, while this conversion is controlled by the AC input signal. Amplifier notation. As you can see from the figure, VDS is the DC source supply. VS is the open circuit voltage of source. VI is the input voltage of the amplifier, because there is a resistance of a source also, or some type of resistance we can attach over there for a better stability. Therefore, the input is not exactly the open circuit voltage of source. The input voltage that has actually given to the amplifier is VI. Vout is the output voltage coming out of the amplifier. IS is the input current, input source current. Iout is the output current of the amplifier. RS is the resistance of the source. Internal resistance may be of the source, but it is there as a resistance of the source. RI is the actual amplifier resistance. That means when you disconnect the source and when you look or attach DMM between the input terminals, you will find the input resistance of the amplifier, which is different from the input resistance of the source. It is the input resistance of actually the block diagram of amplifier RI. Similar way, output resistance of the amplifier. That means the output or resistance of this block. If you disattach this load and attach the DMM between the output terminal, you will find some resistance of the amplifier output terminals that is known as the output resistance of the amplifier. Finally, the load resistance RL. Gain. Since amplifier is not only amplify a voltage, it can be amplify a current also and overall power of the circuit also. Therefore, the amplifier gain are different, such as voltage gain AV. The voltage gain of an amplifier is defined as the ratio of the output voltage to input voltage. Okay. Such as AV is equal to V out divided by V. Similarly, Current gain of the amplifier is defined as a ratio of output current to the input current, that is I0 divided by I. Power gain is also a ratio of power delivered by the amplifier to the load to power the given circuit of the amplifier. It's an input terminal. So VPO divided by VPI. Input resistance. It is also a ratio RI of input voltage to the input current of the amplifier. Output resistance of amplifier RO is the output voltage to the output current of an amplifier. Decibel gain. It's the power gain of amplifier in the base of the algorithm ratio used to express an increase or decrease in the power in a circuit. Therefore, power gain is actually 10 log of 10 to the base power P output divided by Pi, and this is what in a decibel. Now, that power is actually voltage square divided by resistance. If we replace output power with the output voltage square divided by resistance, input power with the input voltage square divided by resistance, we will get the voltage gain in decibel. That is 10 log of 10 V out divided by V input whole square. That is, if we take 2 downside 20 log to the base 10 V out divided by VI, that is AB. Similarly, we also know that power is equal to current square into resistance. If we replace the above equation for the current gain, we will get current gain as a 20 log to the base 10 I out divided by II, that means 20 log to the base 10 AI. Advantage of expressing the terms in decibel or gains in decibel. When the gains are expressed in decibel, the overall gain of the multi-stage amplifier is sum up of gain of individual stage in decibel. It will make you easier to add the gain and find the final gain of the circuit. The unit decibel is algorithmic unit. This unit tallies with the natural response of our ears. Frequency response and the bandwidth. Variation of voltage gain of amplifier with the frequency of its input signal is actually known as a frequency response of amplifier. The curve is shown over here. Curve the voltage gain and the input signal frequency of an amplifier is frequency response. It's normally expressed as a graph of voltage gain AV versus frequency, or power gain AP versus the frequency. Here, when the gain rises with the frequency, the low frequency, and became a constant in a middle frequency and falls in a high frequency region. The bandwidth is actually the difference between the half of the AP divided by 2. We will get the 2 cutoff. Now, the difference of these 2 cutoff is known as a bandwidth. This is the range of frequency over which voltage gains or power gain is equal to or greater than 70% of its maximum gain. That is known as a bandwidth. Bibliography for the above is, you can see, Electronics Devices and Circuit, Salivahanan, 1999.